Let's say we have the following attribute blocks: two large blue triangles, two large red triangles, two small blue, and two small red triangles. Take a moment to reflect. How are these blocks alike? How are these blocks different? So let's reorganize our shapes so that I have the blue ones on the left and the red ones grouped on the right, which is just one way that we can say that the blocks are alike. We have the alike blues and then the alike reds. However, they're different based on color and size. Then let's go one step further. And what if we reorganize them into 4 different groups? Let's compare each group. So I can see that I now have separated them into large and small triangles. And then within them, I have separated them into colors. So identifying different attributes of each type of object is also important. You can grab a cluster of different attribute pieces and redo this activity over and over again in many different ways, asking similar questions. Suppose we have the following. We have a large red triangle, a large yellow square, large blue triangle, large red square. What shape do you think will come next? Outside of just the shape, also examine the rest of the pattern if you're struggling with identifying what the shape is. Stop, take a moment, pause the video before moving on. Did you guess the large yellow triangle? Another way of looking at patterns is, let's say we have pattern blocks and let's make a house. So we're going to use a square with a triangle on top and the square is on the bottom. So at this point we can also talk about arrangement, where things are located: above, below, on top, underneath, next to, etc. Let's keep expanding. So the first item was a triangle with a square underneath. 2 houses would be 2 triangles and 2 squares. Expanding once more would be 3 triangles and 3 squares. In this pattern, the houses are getting bigger. This is known as a growing pattern. What do you think the 4th house will look like? Go ahead and draw a sketch of it, what you think it'll look like. Pause the video, draw a sketch, and come back. Were you correct that you would have 4 squares and 4 triangles? You can make an infinite number of different growing patterns as well. They can get really fun using your imagination. The last cluster is geometry. Students need to identify and describe shapes such as squares, circles, triangles, rectangles, hexagons, cubes, cones, cylinders, and spheres. So not only 2D but 3D objects. So they need to describe objects in the environment using names and shapes. Describe terms such as above, below, beside, in front of, behind, and next to. Correctly name shapes regardless of their orientation and overall size. So it doesn't matter how big or small they are. If they're turned upside down, right side up, they can identify the shapes. They can also identify shapes as 2D or 3D. They need to analyze, compare, create, and compose shapes, such as identifying sides, vertices, or corners, and other attributes of 2D and 3D shapes. Model shapes in the world by building shapes from components, and then as well as compose simple shapes to form larger shapes. Can you join 2 triangles with full sides touching to make a rectangle? So the common manipulatives that you might see are 2-dimensional and 3-dimensional shapes, attribute blocks, pattern blocks, pangrams, geoboards, and a variety of cutout shapes. So we're just going to touch on a few, and with anything that we're going over in K through 5 this semester, we're just really just touching the surface on the different ideas and ways to get you started. There are an infinite number of ways, and you have all year long to cover 2 weeks worth of what we covered. So use this as a touching ground to just get a feel for what students are covering. And it's by no means all inclusive. So keep that in mind as we're going through. Let's say Miguel and Felicia are making shape collages in class using paper cutouts of attribute pieces. Felicia wants to only use shapes with 4 corners and 4 sides. Miguel finds 2 shapes for Felicia to use. What shapes are these? So let's say, let's go through this as a class. We see that the square has 4 sides and 4 corners. Place a bear on one of the sides of the square. So I put a bear on my side. Now let's place a bear on a corner. So identify a corner now. We would then be able to have 4 bears per corner, and that we would have 4 bears per side. So identifying a square having 4 sides and 4 corners. Here we have a triangle block. A triangle has 3 corners and 3 sides. Let's put a bear on each corner. When we put a bear on each corner, how many bears did we use? We can count them. 1, 2, 3. So a triangle has 3 corners. How many sides does a triangle have? I could move my bear to the sides here, and I see that we have 1, 2, 3 sides. Here we have a circle. Can you put a bear on a corner of this shape? Can you put a bear on a side of this shape? This is probably where you're looking at your screen funny and saying, what is she talking about? Of course we can't put a bear on a corner or on a side because circles do not have sides and circles do not have corners. So that's why my bears are hanging out over here, because they don't have anywhere to go. Another problem, as Amanda looked around her classroom, she wondered, what things that we see are shaped like circles? What things that we see are shaped like squares? What things that we see are shaped like rectangles? And I have a spelling error. What things that we see are shaped like triangles? So I've created 4 different boxes, one for each shape. At this point, I would have students find objects and place them in their corresponding attribute circles from around the classroom. And I would purposely put things out that would match. So in addition to what's already in my classroom, so that students can grab and touch. And this would be a whole classroom experience. Then we would go through and we would ask, how are the objects the same as a circle? So we would go through them. Let's say I had a roll of tape. I would put it in the circle box here, or the circle. And students would say, well, this is a circle because it has no edges and it has no corners. And hopefully they would see with all those objects, like a button has no edges or sides and it has no corners. And we would go through each identifying piece from a square to a rectangle to a triangle. And then most importantly, following up with, how do you know whether or not the things you choose are shaped like a circle, a square, a rectangle, or a triangle? So again, reiterating, why is it the way it is? So that you know that students have a deeper understanding of shape attributes. Mrs. Chow asked her class to guess which attribute shape she was thinking of. She said it was small, thick, and red. It had no sides and no corners. What shape was Miss Chow thinking of? We know that the piece has no sides and no corners. So immediately, we can get rid of everything below the circles here, because those all have sides and corners. So now we need to look at our different pieces here. We know that it has to be small. So that means we can eliminate the whole top row because those are all big. Well, we can't see the thickness of it, but we do know it's red. So the piece that she is thinking of is the small red circle. So what we did right there was tell what is the same and what is different about the attribute pieces, which is very important for students to go ahead and pick a whole bunch of different kinds like that. What if she was saying, I'm a block with 3 sides and 3 corners that is big, thick, and yellow. What shape am I? So I eliminated all of the attribute pieces that did not have 3 sides and 3 corners. So I was left with all of the triangles. We also know that it is big, thick, and yellow. So that means I can eliminate the other big ones, and I can eliminate the little guys because we know it needs to be big. So we see that it is the big yellow triangle. We can repeat this activity using a variety of descriptive words for each of the different attribute pieces. Further, as students get more comfortable with them, you could talk about them and have students describe an attribute piece to a classmate for them to try and guess and play back and forth like that. Rory brought a building block and a rubber ball to school to play with during recess. When it was time to go outside, Rory reached into her backpack and grabbed one of the toys. So at this point, it's good to identify that solid shapes are very different than flat shapes. So holding up a cube and a square, how many sides does a cube have? Well, we can see that it has many more sides than a square. A square has 4. Further, how many corners does a cube? How are these objects alike? How are they different? So one could be pointy, one can have multiple points in our hands. They're different because I can't see around one of them when I'm holding it up. Let's look at the marble. How many sides does the sphere have? How many corners? 0 and 0. How many corners does the sphere have? And the circle. So they both have 0 corners and they both have 0 sides. So that's how they are alike. How are they different? Take a moment to write a few things down on how you think that they are different. So let's say I have a paper bag here, and I have a bunch of different objects that are in this bag, and they feel hard, pointy, and have corners. What do you think might be in my bag? Take a guess. Did you guess a cube? Because you're correct. In a second bag, I have objects that feel round, smooth, and have no corners. What could be in this bag? Did you guess a sphere? You're correct. So putting objects in bags, having students describe what they're feeling is an awesome way to also accentuate different attributes of those pieces.